Well, welcome everyone. Thank you so much for joining us today for the Grasp on Robotics series. As a quick reminder, this and previously recorded talks can be found on our YouTube channel and website. Also, throughout the talk, please submit your questions using the button at the bottom of your screen. These will be answered during the Q&A panel at the end of the talk. Now, I would like to introduce our Grasp faculty host for today's talk, Dr. Ani Shi, Deputy Director of the Grasp Lab and Research Associate Professor for the Mechanical Engineering and Applied Science Department within the School of Engineering here at the University of Pennsylvania. Thank you very much, and please enjoy the talk.
Thank you, Gabby, and welcome to this week's Grasp on Robotics. It is a great pleasure to be able to present today's speaker, Professor Jodi Forlizzi. I first met Jodi at a tech workshop to connect Czech AI researchers with US researchers at the University of Maryland. And Jodi was one of the leading experts that was on the panel on human and machines symbiosis. It was a very, very exciting and interesting discussion that she led. She is the Geschke Director and Professor of Human-Computer Interaction in the School of Computer Science at Carnegie Mellon. Her work focuses on design centered around human-robot interactions, human computing, assistive technologies, education, just about anything that involves humans interacting with technology. She is responsible for establishing design research, basically as the third pillar, right, in the field of human-computer interaction alongside scientific and human science research. She is an Academy member of ACM's Special Interest Group on Computer-Human Interaction. She is a recipient of a Walter Reed Army Medical Center Excellence Award and a Design and Emotion Slow Glow Award for Excellence in Design Research. She has also recently been awarded an honorary doctorate in Design and AI from Eindhoven University of Technology in the Netherlands. So Jodi, it's a great honor and pleasure to have you with us today. So we look forward to your talk. Please go ahead.
Thank you. I'm sorry for running late, everybody. My computer decided to update itself a few minutes before we started. So thanks for your patience. I'm really excited to be with you. I wish I could be in Philadelphia. I lived there for many years, and I actually worked at Penn in the LRSM doing graphics as an undergrad. So I really wish I could be with you. But today I'm gonna just take some time to share thoughts with you about my field, design and human-computer interaction, and how they're applied to the study of robotics. So by way of introduction, I'm trained as a designer and I work in human-computer interaction. And all of my research and practice happens at the intersection of technology and design. And as you heard, I teach and do research in service design, human-robot interaction, educational games, and design and AI. And what I'm going to do today is talk a little bit about my field of design and how it's impacted by advances in technology. And then I'll return to some of my research on human-robot interaction and talk about how design has been impactful there. So there are many, many definitions of design, and I want to start with Donald Schoen's description of design as a reflective practice. In his writings, he talked about a jazz musician playing music, and the jazz musician is very accomplished and fluid, and at times they might depart from the musical score and improvise. And Schoen called this reflection in action, insight that arises from taking a step, sometimes an unplanned step in a design process. Schoen also talked about a design critique, which traditionally is done by gathering people in a room, putting work physically on a wall, and then creating some insights that come from taking a step back and contemplating the design process. Schoen also talked about backtalk, which is this idea that designers work with materials and they understand how they speak back to talk about their possibility. So if I were going to train you to work with wood or clay, I could give you a lecture about it, or I could send you into the studio with the material and ask you to get a feel for it by working with it, to make things and critique them. So collectively, these actions are the design process, which Schoen called a conversation with material. So reflection in action, reflection on action, and backtalk allow designers to give form to a thing. So design then is an investigation using this design process. And what designers do is understand the current state and then imagine the future and how to improve the future by what might be designed. Then we give form to something through a conversation with material. Now, Buxton, who is also a famous interaction designer, talked about this notion of reframing, where we find the problem behind the problem. And he talked about making the right thing. And then once we know what the right thing is, we refine it through prototyping and iteration. And Buxton called this making the thing right. So these notions of creative processes, giving form with material, and reframing and iterating are common to all design processes, whether we're designing something simple or something complex. And it doesn't necessarily mean that all designers would come up with the same solution. So if I tasked a group of designers with creating fresh drinking water, some might create bottles to carry drinking water. Some might create pumps to draw water from the earth, and others might create policies to bring fresh drinking water to populations. And none of these are wrong. They're simply the right solutions for the right context at the given time. So a big part of designing is this notion of reframing. So a frame is an assumption or a perspective on a situation. And for designers, framing is often seen as an initial creative step, getting to the problem behind the problem. And then reframing is challenging our current assumptions to make sure that we are moving through the design space in a desired way. Now, interestingly, technical innovation typically does not reframe, but design innovation does. And therefore, many design innovations follow technical innovations. So we can think of reframing as the dialogue between technologists, designers, and users. So for example, in 1962, Philips created the cassette recorder. They have the technical capability of recording something on a metal strip. It was a set of capabilities, but not really for anybody specific. Then some design innovations came and we saw valuable new forms for the cassette, like the Sony Walkman, boom boxes, car stereos. And we saw new social practices like making mixtapes that yielded these two tape recorder systems. Home answering machines, again, were a design innovation that took this technology in a new direction. You can also think about Uber. So Uber started as an app and a set of cars, and it was actually a black car service to rival limousines. Then it pivoted or reframed to an event car service. Then it pivoted again to a cheaper, more reliable form of taxis where we had more drivers, more riders, and more data. So these initial innovations and pivots were actually economic decisions, not technical. And then Uber pivoted again, and they began to do things like transporting people to vote. And they pivoted again by having Uber Eats, which is not only a car service, but could be a person on a bike, a delivery robot, bringing food. And so now Uber is a transportation service where people are but one thing that they can transport. And as we know, they had autonomous vehicles and delivery robots, and then they themselves were acquired. So as technology changes, it also impacts the field of design. And this affects both design research and design practice. So I'm at Carnegie Mellon University, and the presence of the Human-Computer Interaction Institute and the Robotics Institute within the School of Computer Science have been really impactful in my work. Most designers don't get to build their own robots. We would instead study systems that exist or propose small modifications. And so our group has been able to work in this context of a vision of robots and autonomous systems that will someday interact fluidly with people. But as we know, we're not really there yet. And so this is a really fertile ground to apply design research, where you can quickly cover a design space, reframe, develop prototypes, reframe again, test again, and then have a better idea of what to build, often without committing really expensive technology and resources. And so today, data, machine learning, and artificial intelligence impact what and how we design. So there was an article in The Economist last year that decreed that data in this century is what oil was to the last one. And it's true, data has enabled new products, services, businesses, and even economies. And so machine learning and AI play a role in what we design because they have a huge role in defining autonomous behavior. And machine learning and AI affect so many aspects of what designers touch, ranging from web-based services to conversational UIs, to apps and social media platforms. And a huge need, I think, is to teach designers and to get designers collaborating more with technologists. Another thing that is really confusing is that we don't even know what we're designing anymore. So if we look at these devices like the Google Home or the Amazon Alexa device, they are commodities, they're products that people buy and take home, but they also have a service component, which in many cases people pay for. And so I think it's an interesting idea that for designers, products and services are blending. And so we have product service ecologies, which come from efforts towards servitization and productization. So servitization is when services are added to products, such as IKEA, who added home delivery and build services to the commodities that people buy in stores. And productization is adding products to service organizations, such as Warby Parker, who added physical stores to their online presence. They wanted to have welcoming customer experiences around buying glasses. And then we have yet another layer, which is datafication or data animation. So data can be added to products, and this results in products like smart thermostats and water bottles. Data can be added to services to help make predictions about maybe what part you want to buy for a repair when you go to Home Depot to get a component to fix your toilet. And data can be added to product service ecologies, and this results in these comprehensive systems that make predictions and offer actions that may have impacts a long time forward in people's lives. So one that I like to talk about is this set of services for college counselors, for example, to look at a student's trajectory and predict whether they're going to succeed in their chosen major. So that's an interesting use of data across a number of products and services that may have ethical and long-range impacts for people. So I developed this framework called the product service ecology to characterize this shift towards these more complex constructs in design and to sensitize designers to all of the factors that are important in designing these new and complex things. So this has become a useful construct in our research. So in many cases in both design research and design practice, we need to envision a future that has never existed. So we use design research to understand the current state, identify and improve future state, and then design a new thing to advance towards that preferred future state. And of course, this future might integrate machine learning, AI, robotics, and other technologies. And often in these domains, we run the risk of designing something that might fail. So design research is good for imagining the future when you have new technology and new settings that's expensive to develop, that people may not accept. Design research can be good when we don't have any design conventions or social norms. You don't know how people are going to use things. And design research can be good when we have a technology, but we don't know yet who the users are. So we use design research in all of these cases, not only for design practice, but for design research, so we can reframe our research directions and discover new knowledge. So if you have a very vast and complex design space, like designing fresh water, then you might want to use design to sort of mine through the design space and figure out where the best, most viable solutions might be. So we invented this method called speed dating to help do this. And it helps us to push the boundaries of what people want and what they say they want. And this method is modeled after speed dating in real life. So in real life, when you go on speed dating, you sit at a table with props and you have many fake quick dates. And at the end of the night, you probably haven't met your ideal mate, but you have a much better idea of what you do want in your ideal mate and what you don't want. And so speed dating as a design method works similarly. We expose people to a number of conceptual designs. Sometimes they're semi-functional prototypes, sometimes they're demonstrational prototypes, and we can get them to make some judgments about the future in terms of what they want, what they believe they want, and what they really need. And so there's two basic types that are quite easy for anybody to do, even if they're not trained as designers. The first are storyboard scenarios. These can be done with hand sketches, with components that can be taken off the internet. They can be done virtually. And we call this sketching with narrative. This focuses on placing a character in a setting with a need, exploring a solution, often in vague terms. You don't talk about what buttons or what AIs are working, and then looking at the resolution, and we can see how people respond to those. And the other we call user enactments, which can be quite elaborate. And these are designed to focus on social interaction around technology. So the example on the right is actually really simple. We were tasked with focusing on the interaction between teens and parents around finances. And this was a loan tool that is actually an Excel spreadsheet with fields locked down. And the parents and teens could work through this together. And once we knew that it was the right thing to do, we could actually build it into a more viable concept. Here's another more elaborate user enactment. And this was to explore the value of virtual things for young adults in constructing identity. So these are things that once had a physical form, like photos and money and books and music, but are also things that were always digital, like social media, like tags and traces. We constructed this team bedroom in our lab. So rather than building working technology, we essentially made this stage set, and then we used CAN data to create these demonstrational prototypes, which allowed us to explore this really vast design space without committing a lot of resources before we knew what to build. So in this slide, you can see us beginning to build the bedroom. A lot of the concepts centered on access to virtual content through a variety of physical displays. So we used a projector. In this slide, you can see on the left-hand side, we're building an experimenter area where one researcher controls the enactments, and then the room is unfolding on the right. And the interfaces were projected onto mock screens. So we constructed these out of foam core and black tape. So here you can see the simulated setting, the simulated room, to begin to prepare for our teenage subjects to come in. So we asked pairs of participants who were friends to come into the bedroom, hang out, read homework together, and then we ran the user enactments. And for this group, we learned that details were really important to suspend belief. So in this picture, you can see how we covered the door of our lab with foam core to make it look more like a home. And we also played music. And so this setting was a really revolutionary turn in our research. It attracted a lot of attention on campus, and it led to a lot of findings about the value in these data and these possessions, these virtual possessions that are placeless, spaceless, and timeless. And we also understood a lot about how these are used differently by people in their teens versus their 20s. And we even did some cross-cultural studies with people in Spain and Korea. So turning back to human-robot interaction, I want to talk a little bit about imagining the future of HRI using design methods over the past 20 years. So my HRI research began when we designed the SnackBot because we wanted to design a robot that we could study long-term, varying aspects of its design and behavior. So we chose a robot that delivered snacks in our campus buildings because everybody's working and people like to eat. And a team of almost 15 faculty, staff, and students worked for about 2 years to design and develop this robot, reframing our assumptions about what a robot that served an academic community over the long term might be. So here's a video, SnackBot at work.
I have an order for Patty. Please take your cookies. Thanks, Kathy. Enjoy your snack. I hope you have a wonderful day. Goodbye.
So the Snackbot had a web service where people could opt in and order fruit or cookies or candy 3 times a week. The robot delivered snacks to offices. And this robot was a focus of study for nearly 6 years. We varied aspects of its design and behavior. We began to understand how people would interact with robots over the long term. We studied the effects of different design features and different service strategies. And we did this by looking at the robot as a product service ecology and by using a lot of prototyping to understand how to move forward with design. And even though we were working with roboticists, at times we stepped back from using our own software and hardware, and we used off-the-shelf components to make the research progress faster. So one of the first places we used design research was to understand how robots should recover from failure. So for example, this video of a robot making an error led to some pretty formative research on breakdown and recovery and how it affects the trust of a robot. So in this video, which I'm going to play in a minute, the robot's delivering a drink to a bin in the front of the frame, and it fails. And in watching this movie, you can hear how committed people are to the robot being successful. So people were pretty upset when the robot failed, and this launched this idea about how we could mitigate the effects of robotic breakdowns. So we used design research methods here, and we looked at these 2 service robots, Snackbot on the left and Herb. This is an early instantiation of the Herb robot on the right. And our breakdown focused on perception because it's a problem common to robots. So our research questions included, could we design a recovery strategy that works even before a service breakdown happens? And what recovery strategies are best for technology-driven services? And are they the same as in human context? And then should recovery strategies differ depending on the customer? So research in technology acceptance shows that there are 3 different cultural models that people typically evoke when they're interacting with technology services. The first is a relational model. People want to have a positive social and emotional experience when they interact with robots and other technologies. The second is a utilitarian model. People don't want to have a social or emotional experience at all. Instead, they want to maximize their value for the time spent interacting with technology. And then a third model is the oppositional model, where people don't trust the technology and they may not want to interact with it at all. So we wanted to explore these cultural models to mitigate service breakdowns, and we wanted to do it in a lightweight way without building a million different kinds of robot behaviors. So we used these scenarios, and in the scenario, Chris is a person who is thirsty and asks the robot to bring a can of Coke, and the robot says, okay. Then the robot goes back and it makes a perception error. It looks at Coke and Sprite on the counter, and it brings the Sprite instead. And then based on these cultural models, we varied the robot's behavior. In one condition, it did nothing. In a second condition, following from the relational model, it apologized for bringing the wrong drink. This is really simple and it works very well with people. It conveys politeness, courtesy, concern, and empathy. And we wondered if it would work with a robot. In the next condition, the utilitarian frame, we offered to bring a free drink. This is because in the literature, compensation has been shown to make people feel better after they lose time due to a robotic breakdown, and it enhances the perception of fairness and service. And then finally, based on the oppositional model, the robot offered to go back and get the right drink. And this is because people may feel like they don't have control when they're in their oppositional frame. And so this option to get the right thing may reinstate the sense of control. Now, in half the conditions, we also warned in advance that the task was hard and the robot might make a mistake. And so all of these conditions were tested in an online study where people looked at a video of each robot and then rated the robot and the service and the perception of whether or not they would use it again before and after reading the scenario. So forewarning users that the task is difficult for the robot significantly improved people's judgment of the robot, but it didn't increase their willingness to use the service again. And the three strategies, apology, bringing the right drink, or giving a free drink, showed that even across cultural frames, which we could test for and reliably predict, apology was the most effective. So forewarning and apologies were more effective than offering a free drink or other options. When the robot apologized, people felt it to be competent and they felt closer to the robot. So this design study gave us new knowledge about cultural models and personalized service. It showed us that being able to predict these cultural models would result in better human-robot interaction designs, and that we might foster better collaboration, better trust, and better reciprocity. We also use design methods to understand how people make sense of robots, and this changes over the long term. So again, using SnackBot, we used a 4-month delivery study on campus with the following questions. Would people accept social robots helping them at work? Can robots be designed to help people accept them at work? And to do this, we conceived of 2 types of behavior. One was a social behavior where the robot chatted about things that it knew about the organization, Carnegie Mellon, the weather, campus events like Carnival. And then in a second condition, the robot offered personalized behavior. For some people, it offered them a special snack. It asked for help or advice, and it offered to do a neck stretch with people. So we wanted to know if people's behavior would change over periods of time interacting with the robot in these conditions. So in our study, we had 2 groups. Everybody received the social behavior condition for the first baseline period. And then in the second period of the study, half the participants received the personalized condition. We had a lot of data to study from this work because we had 4 months of about 40 participants ordering. And we measured how much they liked the service, the rapport with the robot. We measured numbers of orders, how long they conversed, how many turns they took. We had measures of cooperation and reciprocity. We could measure whether they got up out of their seats, whether they smiled, whether they used a pronoun or addressed the robot by name. So there was really a lot to understand from this very lightweight study. We found that the social condition helped people to enjoy their experience of using the snack service. They ordered more and more snacks as the weeks went on. They exhibited social behaviors back to the robot, like gift giving, and in some cases, they even exchanged personal information. So in this video, we have a participant who the robot broke down in front of her office for about 45 minutes. And then the next day when the robot came to deliver, she had a snack for the robot, which is a battery. So you'll be able to see her giving SnackBot his gift of a battery. Oh, sorry about that.
Please take your orange. Thanks, Donna. Enjoy your snack.
So she said, I have a snack for you, SnackBot. And not only was she conversing, the people in her area back there were also really excited. So there was a lot of social evaluation of this. And in fact, when the personalized condition launched, some people became very jealous that the robot liked the people who were getting personalized service better. In this video, we see an excerpt of someone relaying personal information while in the social condition. He's talking about living in California and preferring to live there over Pittsburgh. I wonder why.
It is cloudy and overcast today. It makes me feel sleepy. I hope the bad weather is not bringing anyone down.
Yeah, I don't know. That's true. I am a little annoyed at the weather. I wish I was back in California. That'd be a lot better.
So as it turned out, people who received the personalized condition had even more increased interaction with the robot, and they also had increased satisfaction with the service. But we saw some interesting effects. There were ripple effects in the organization. So people who didn't get personalized service, as I said, became jealous, and they believed that the robot liked others better than them. And I should also mention that these are employees in robotics. So it's not like robots were alien to them, but they really developed a lot of social feelings around this robot's personalized behavior. So here's a video of the robot offering to do a neck stretch, one of the personalized behavior conditions, and he complies.
By the way, taking a break has been shown to boost people's productivity. I know how to do neck stretch that can help release the tension around your neck and shoulders. Would you like to try it with me? You can follow along as I demonstrate what to do.
Okay, let's do it, Smackbot.
First, tilt your head forward so you are looking down at the ground. Then tilt your head backwards so you are looking at the ceiling. Okay.
And so forth. So we saw a nice compliance there of the request to do the neck stretch. In this video, we have a participant pretending to be someone else. So one of the conditions in personalized service was getting a mystery snack. So you may have ordered cookies or fruit, but the robot would bring a white bag with a question mark, which was actually a custom cupcake from the bakery. So we had a lot of foot traffic to the bakery during this study. So this created a lot of envy and excitement. And in this video, someone's pretending to be someone else so they can get the mystery snack.
By the way, I am carrying a special mystery snack today. I cannot tell you what it is because it is special. I can tell you that it is really fresh and good. Would you like to try the mystery snack today instead of the Reese's that you ordered?
Sure, I'll try it. Yeah.
So you can see there was a lot of social excitement. So this study revealed some new knowledge about robots and organizations. It taught us that we have to understand fluctuations within a workplace where robots may be programmed to do very similar things in very similar wings with similar layout, sensing, actuation, but very different organizational demands. And so we have to understand people's roles, their inclination to technology, and whether they're interacting with the robot in private or public settings. So our design research can also help us understand now this very more complex space of human AI interaction, human robot interaction, and human agent interaction. And so this is where a lot of my research is focused recently. So we're starting to consider questions like, should a Google Assistant drive my driverless car and interact with me on my phone? Or if I interact with a conversational agent at someone else's home, is it my agent? Should it be? Am I leaving personal information behind? So collectively, this research investigates this near future, full of ubiquitous robot agents, where we have many robots and many agents interacting with people across many settings. So we're investigating how these intelligences should appear and be designed in multiple re-embodiments and work across forms ranging from tabletop robots to social robots to robots in factories, to screen-based agents, conversational agents, and others. Some of the questions we're wondering about is, how are elements of context inferred as representations move from device to device? How are humans transferred among these systems? And we've been using design research to explore this space and to elicit responses to technology that does not yet exist. I should also say that a lot of this research has been done in the pandemic, so most of it is virtual. So what we know so far is that people are generally comfortable with robot agent systems. especially in some contexts such as home or private spaces, but less so in public spaces. We know that people understand and can accept re-embodiment, and that they model this behavior around human social norms. So for example, a robot that moves from place to place with you as you move through the hairdresser or the dentist office should do things like give confirmation, should show when they have expertise, should use social cues like social talk to build fluency. But they should not talk at the same time if there's multiple agents or robots working at the same time. And then we saw some tensions, and these center on things like cognitive overload. So even though these are computational systems, people worry that they will be able to do all the tasks at hand. People worry about expertise, they worry about privacy, and they worry about crossing contexts in ways that would seem consistent or comfortable. So there's many times when we are still not sure how the interaction should be designed and when people would be comfortable or uncomfortable. So we're exploring some of these arenas in our current work. So we're asking questions like, in what context are people comfortable with agents and robot systems? So for example, should re-embodying agents be owned by one user? Should they access information of one user or many users? When should agents and robots possess particular social or technical qualities? For example, when these agents act human-like, should they understand social roles of their users, or should they understand who else is around? Or when should they act more like computers and rely on an express knowledge that computing and AI systems might have, such as deep knowledge across a number of domains? And then who should agents be accountable to? When agents are used in social settings, is the notion that they're owned by somebody important. So for manufacture of future agents and robots, this may tie into this concept of products and services that I talked about earlier. So again, we're using the speed dating method. Now we're using something called structured speed dating, where we try to compare the same constructs over a set of contexts. So for example, if we're looking at this idea of moving from context to context, we might look at a robot or agent that knows about you in the front desk of a hotel versus a Department of Motor Vehicles. It might know about you at the front desk of a hotel when you're traveling with a work colleague, and then would it reveal personal information? We might look at when one robot or agent does things across several steps in a context, such as a robot or agent could take your ticket on an airplane and then pilot the plane, or a robot and agent could take your ticket on the plane and then run the in-flight entertainment system. So these again can be storyboards or build environments. We have been working with build environments like you see in the left and center panels. And now in limited access to the lab, we have also been working with the sketches. So some of our claims under exploration: people will be bothered when a robot or agent identifies them in a service when they would not expect to be identified. People would be less bothered by being identified when this information is used to deliver something of value. And people might not want robots to re-embody when they involve a large change in social role or expertise. So for example, in identity or the expectation to be recognized, what we found was that people thought it was normal and valued if it came in an environment where they would expect to be recognized. So in the experiment, you can see Pat's at her oil change place, and the agent there recognizes Pat's car, and knows what kind of oil Pat likes and how long it's been since Pat visited. But when Pat's recognized at a carnival, it's a little bit strange. So it's perceived as creepy if no value is added, like the carnival. And then we see concerns about social and privacy violations. And people begin to ask questions like, what is tracked and what is needed? And how can we relay this in a way that conveys the service in a way that people will trust? For the expectations of competence, we are finding that people seem comfortable when a robot takes on multiple roles with multiple expertise, as long as the agent or robot is perceived as capable of doing both jobs. So returning to the airplane example, taking the ticket and running the entertainment system seems fine. Taking the ticket and then piloting the plane, people still have some trouble with it, excuse me. So when one of the roles the agent or robot takes on is high risk, or the roles are vastly different, people have problems with this expectation of competence. So in summary, in this work, being identified can improve the service, but it can also be creepy. People accept this notion of re-embodiment across robots and agents in low-risk settings, but in high-risk settings, it's not as much accepted. In fact, it can be perceived as unsafe. And if we remain in the same domain, it seems good, but if we have re-embodiment across multiple domains, then it starts to raise concerns for people. So overall, in these studies, our knowledge for HRI and HAI design include this notion that re-embodiment is acceptable in low service contexts. If personalization is required, then the robot should identify the user, but if not, then no. Re-embodiment designed appropriately can improve the service experience unless tasks are in different domains. And one that we're further exploring is, when should people's social roles and affiliations be known, particularly when these systems are being accessed in public settings. So in conclusion, today I tried to talk about the field of design and illustrate how it's changing as new and more technologies are invented. I tried to talk about and exemplify how design methods can be good for understanding how to build these technologies, particularly when social norms don't exist. And some of the ones I've talked about are conversations with material, reframing, design innovation, considering multiple stakeholders, sketching with narratives, building scenarios, and speed dating. What I've found in my years of working with non-designers is that these methods can be straightforward to adopt, and we've found them to be really beneficial in the design of robots, agents, and complex systems. So thanks again for listening, and I apologize for being late. I want to thank my faculty and student collaborators, and also the support we've received over the years from NSF, Google, and Microsoft. Thanks again.
Thank you, Jodi, for a wonderful talk. And so now, right, we're gonna, so I'm gonna introduce our student panelist. So first off, I would like to introduce Tori Edwards. She is a first-year PhD student in the Mechanical Engineering and Applied Mechanics department. So outside of the lab and during her sort of, free time, she likes to cook, knit, and you can find her on the beach, sort of practicing safe social distancing. Our second student panelist is Fariha Tamboli. She is a Robo MSc student. During her free time, she enjoys dancing and choreographing for short films. So they will be manning the Q&A session. So go ahead and get started.
Hi, thank you so much for your wonderful talk.
Nice to meet you both. Yeah, thank you.
Great to meet you. You touched on some of the implications that COVID-19 has had on your research, and we were curious, because you're a designer and you're thinking about the future, and no one could have predicted COVID-19, where do you see your speed dating studies and some of the other design techniques that you've been using to do research evolving to now that we are more virtual and with a potential expectation that it'll be this way for some time?
That's a great question. Thank you. So some of the things we're doing, first of all, I want to comment as a department head. I am so worried about the ability for research to carry on because everything is changing. Conferences are virtual. We know that face-to-face interaction is so important. Who's attending these things? How are we seeing each other? How are we networking? I hope that we can find ways to preserve that. And I think that's really important. In my research group, we've been judiciously trying to combine small slices of work in the lab and in-person interaction with a lot of virtual stuff. And it's been going okay. We have done things like also built small technology components and ship them to users, train people to use systems and put them in place to collect data. We've embedded things in places like cars so we can still collect. So I think what we will see is some combination of virtual work and then carefully embedded physical work. And I also think that we are really going to rethink how we use the academic lab and office. I think that's really going to change. I don't know how it is in your department, but we are really short of space at CMU. So we've been packing people into these labs, and suddenly in the past year, things are still getting done with very few people around. So I think those are all interesting questions. So I probably have more questions than answers on that one.
Hi, thank you so much for your talk. So is there any lesson that you and your group have learned while pioneering a new area of research?
Well, I think the best way to get people to understand your discipline when it's not common is to give them an example of working directly in the discipline. So when I was a new faculty member, I was the first designer hired in computer science, and nobody really understood what I did. And I remember somebody coming to me and saying, "Hey, we need a cartoon drawn. Can you do that for us?" And I thought, oh my goodness. And actually one piece I didn't include in my talk was right when I became a faculty member, there was a robot, Pearl, that the technologists had built, and the robot's head cracked. So we had when I was asked to fix the head, so we had a real opportunity to not only fix this head, but do design research. So we created this modular head that you could vary the height and the perceived size of the eyeball, the perceived width between the eyes, and we turned it into a research study that was like the first HRI study published in a design conference, and then we ended up getting this really big grant. So in working with across the disciplines with that work, we were able to begin to show how the methods worked, how design unfolded, and what benefit it could bring to the research. So small things. So those scenarios, I have my technical students using them, and it's working really well. It's now become kind of an accepted way in the HRI area at CMU, but it took a lot of work. So.
Thank you. We have questions rolling in from the audience. So
Great.
we're going to start fitting those in. People are excited to hear more from you. So the first question we're going to touch on is someone asked during the talk, who should be the benefactor of robotics technologies? And what do you envision being the most important application for robotics in the coming decades?
Oh boy, that's such a hard question. Well, I want to talk about one of my projects that is exemplary, I think. So right before the pandemic, we began working with the largest hospitality union in the US to prepare their workers for a future of automation. And many of these devices are these crazy, hastily designed robotic systems like bartenders. Some of them are AIs that tell the hospitality staff how to go from room to room. And others are things that used to be handled by hotel concierge, which now are done by app, like ordering food or getting a car. And by and large, these things are displacing female, uneducated people that are out of a job, or their expertise is minimized, or their inability to do the social work. So when the automated bartenders came, cocktail waitresses laughed and said, you're going to waste a lot of drinks because we know who the people are, and we know where to take the drinks when they move from machine to machine in the casino. And they're doing a lot of social and emotional labor. So one of the things I think we need to be careful of is when we get to the general public, we need to make sure that we're accounting for people's expertise and labor and how they do the work. So yes, robotics has an important place. And if you look at graphs comparing the economy versus the number of robots built, we always see in the years when there are more robots in the US, the economy is strong. But I think we need to keep a hold of this thread that we are helping people to do their jobs better rather than merely displacing people. So I think we're going to see a lot of work in that area.
Another student question is, have you done any work studying the use of AI and ML in decision making, for example, automated decision systems? And often technologists try to replace humans with AI or ML. So do you think it's the right approach? And
so some of our other work looks at, I have a lot of, design is a very general discipline. So we work across a lot of things, but some of the work in my institute, we have a large number of faculty looking at algorithmic bias, and we can use the design process to reframe assumptions around that. So in Allegheny County, where Pittsburgh is, they developed this policing software, and it ended up to be really bad. They thought it would help police, but instead it ended up being a privacy concern, and it was unfair to certain populations within the city. So we explored that as a case study and said, if you got all the stakeholders together and used a design process to say, what is being designed, who benefits, what happens when the AI goes wrong, we might actually have a better set of assumptions about what the right thing is to design. Because when we make things, all of us, we bring our biases. So one of the things reframing can do is to help get at those biases and hopefully flatten them. So I think that is an area that might help to address the question. The other thing we can do is to create communicative forms that actually try to show what the algorithms are doing. So there's some work that we're doing, for example, with Wikipedia's ORIS editor. We made a system on top that shows the editors the potential outcomes of their choices, what the algorithms are doing, and tries to help drive them to a decision. So I think that theme that I want to elicit there is like transparency and communication.
Thank you. That was so interesting. And there's another question that's come in that's kind of in this similar vein. And if you are, I'm trying to read it and also like wrap in, you've talked about some bias and other things already, so making sure we're not repeating the same answers. But this one I think is pretty new. Are there scenarios where you see technology as being used because it can be used, where implementers haven't really considered whether the technology should be used? And I especially know, I guess I know that GRASP has spent a lot of time talking about diversity, equity, and inclusion, and the Black Lives Matter movement of the past summer. And I think that some of those things are on all of our minds, and especially how we can start making early design decisions that, because, and a lot of, I think I'm going to generalize, a lot of us are engineers, not designers. So I'm an experimentalist. I engineer a lot of experiments. And I was watching your talk really thinking, how do those tools play into how I would design an experiment? And I'm wondering if that same could be true when I'm thinking about the implications of my work. How do I use those design techniques in that way?
That's a great question. Thank you to whoever submitted, and thanks, Tori, for articulating it so well. Yes, I do think design can be used in all of these agendas. So you may or may not know, but I'm the DEI lead in the School of Computer Science at CMU, and probably like at Penn, since the events of May and George Floyd's killing, we have a lot of people in an activist frame saying that we need to do better in who are our stakeholders, who's around, who are we hiring, who are we accepting into our programs, what research are we doing? And yes, I think that we can use design methods to think of these things. So there is a famous systems designer called C. West Churchman. He was from Berkeley, and he had 9 questions for systems designers, which I think are highly relevant. And 4 that you can tick off on your fingers right now is, what are you making? Who is it for? What is the benefit? And what will be the outcome? If we think about those things and we bring a group of diverse people to a problem or situation, and we all ask those questions, I think we can take a huge step forward. And so some of those very simple actions are the ones that I've used as a department head, that I've used in diversity work. I think that those are really my fabric.
Thank you. Another question that's come in is, can you talk about what backgrounds are most important for researchers in HRI?
Well, that's really a good question. I think we've had a good synergy blending people with computer science, MEC-E, robotics, design, social science, organizational psychology. So we really, in our lab, try to bring together people from different disciplines. So the re-embodiment grant that I talked about in the last part of my talk, we've got 1 student with a psych background, 1 with a CS and engineering background, and 1 with a design background. And they are working really synergistically. Everybody's building some software, everybody's using some design techniques, everybody's using some psychological aspects of their studies, and that's working really well. But there could be other kinds of people, like natural language processing could be important. Game theory could be important. There could be many things, because really everything has a robot of some. If you define robots broadly, so there could be many implications. The other thing I want to say before I give up the floor is the HRI conference, which is my main robotics conference, like you guys probably have different ones, their focus is really on human study. So they really want to get to the human interaction with the robot.
Very interesting. Thank you for sharing. I am going to pivot slightly, but only very slightly. The SnackBot team you said was 15 people. And I know that there is a modular component to that where everyone brings their own niche, their own set of capabilities. But there's also, and I think you touched on this, the holistic sense that y'all were producing a product. So at the end of SnackBot, you had a full functioning end-to-end system. What is the balance of getting the right amount of modularity to the right amount of holistic vision that allowed your team to so successfully implement a system that was obviously very robust and successful for many years to come after that 2-year process?
Oh, question asker, you're far too gracious. But yes, I think that's a great question. And I think that as a team, we sat down, we specified that we wanted a robot we could study at CMU over the long term. And then we focused on snacks, because we knew that was something that would create repeated engagement. Who wouldn't want a robot that brought them fruit and cookies? So we had those things, and then we defined attributes for the system. And then we kind of broke into subsystems. So there was a hardware team, a software team, a fusion team, a HRI team. There was a team working on the dialogue. There was a team working on the interface for the experimenters to control the robots. There was a team working on the tray, which had sensing to detect the presence or absence of a snack. There was a team working on the mouth, So we wove in keeping these overarching goals. I'll also say that a lot of it was a craft process because we had never done it. We didn't know what we were doing. We abandoned things that we started coding ourselves and used off-the-shelf stuff. It took a long time. For example, the housing, we ended up going to a kit car manufacturer and they built a custom housing based on models we made. That was really fun. And then we went to a custom motorcycle painter to get the body painted. So there was a lot of crafting of that. The fabric parts I sewed myself. The speaker and the housing for the speaker, we ended up using a plastic container to amplify the sound. I mean, there was a lot of slapping together of stuff and it was fun. We were conversing with the material, as it were, so.
So kind of off the snack bot, in the paper you mentioned that in an office workspace, they didn't like the kind of American ice cream truck sound. So how do you think that you can adapt a robot like this to other scenarios, like a hospital or an airport?
Great. So we did study a robot in a hospital. I didn't put in my talk because I couldn't get the whole roster in there, but we studied the Atheon tug that delivers linens and picks up, it delivers trays and is loaded with dirty linen. And this robot rolls up to a station. It's very simple. And then it beeps until somebody opens it. The robot was programmed to work in a postpartum ward and a cancer ward. And in the postpartum ward, people welcomed the robot. There was very happy babies, you know, they decorated the robot. They wanted it to sing in the voice of a local celebrity. In the cancer ward, people shoved the robot and cursed at it. And they ignored it when it beeped because they perceived their work to be very time critical and life critical. So that was a really interesting observation about the same robot, same layout, same jobs, but really different uptake depending on the nature of the hospital work. The other thing is we've studied how people adapt to sound and conversational action over time, and people learn and remember things and they want things to collapse. So if I ordered a chocolate chip cookie every Friday from Snackbot, I probably don't want it coming up and giving it the same long announcement every Friday when it brings the cookie. So, you know, some modification I think is needed as people adapt.
Interesting. I'm trying to think of a theme question to ask to end us off on. If there's something you'd like to share with the audience before we close out the panel, this is a chance to do it. Maybe someone will throw in a last minute question here before we end. I was trying to think if there was a way to tie in all of these themes into a question, but I'm not sure I have
Well,
it.
I'll just say we have an REU program. I don't know how many undergrads are in the Zoom, but you know, it's going to be remote this summer. So if you want to work at CMU and you're an undergrad, you can apply. We've got a huge group of people taking on students, and I love it. It's a great, you know, sadly, last summer I had a student from Princeton and one from University of Wisconsin who I never met, you know, just in Zoom, but we had a really good summer. They managed to write a paper, which is fabulous. So you want to do design research with robots and agents, hit the CMU REU HCII site.
Great, thank you so much for a wonderful talk and an awesome discussion. And so I'm gonna turn it now to Gabby to take us out.
Well, thank you so much, and for everyone to join us today. Please tune in next Friday, February 12th at 11 a.m. Eastern Standard Time for our next Grasp on Robotics speaker, Dr. Stephen Lavage from the University of Oulu. For more information on upcoming events, be sure to follow us on social media and check out our website, and also our new live stream option on our Grasp website. Thank you so much and have a wonderful day.